Hello judges, I am Xuan, this is CASPAR, and this is ALPHAEUS. We are a team of Sec 3 students from School of Science and Technology, Singapore. Today, we will be presenting to you on our project. Investigation in the type of soil affecting soil erosion and soil shear strength. Let's start with some background information first.
Singapore has an equatorial climate and receives heavy rainfall. Recently, Singapore has been experiencing such heavy rainfall, it was even reported on the news. Now, our group wondered, would the excessive rainfall affect the soil that were holding up buildings in any way? How do you judge if it is safe to build buildings on a said soil? So, our group did some research and learned that the most common type of soil in Singapore is Rengam soil. With a composition of 32% clay, 6% silt, 12% fine sand and 50% coarse sand, it was hard to source for all of them. Thus, we carried out the experiment using what we have. We also mixed the soils in different proportions to have a larger data set and form clearer conclusions. We concluded that shear strength and erosion resistance are important factors in deciding if soil is reliable to build structures on. We formulated 3 experiments to prove our reasoning. By simulating rain on different types of soil, we became able to determine how resistant to erosion a soil is. Not only that, we also applied force to blocks of soil and piled them out indirectly to measure their shear strength.
The aim of our first experiment is to find out how resistant to erosion each type of soil were. We designed a ramp out of cardboard to facilitate the erosion and a sprinkler to simulate rain. The experiment involved changing the type of soil used, and the data collected would be the amount of soil eroded. What you have seen is an animation of how our experiment is carried out. The aim of the second experiment is to indirectly determine the shear strength of each type of soil. We designed a mold and compressor to make the blocks of soil. The experiment involved changing the types of soil used, and the data collected would be the mass supported by soil before material failure. What you have seen is an animation of how our experiment is carried out. The aim of our third experiment is also to indirectly determine the shear strength of each type of soil using a different approach. The experiment involved changing the type of soil used, and the data collected would be the angle of repose of the type of soil. What you have seen is an animation of how our experiment is being carried out.
Here are our results for the first experiment. We observed that soils with a lower erosion percentage consist of higher amounts of gardening soil that has many fine particles, whereas soil with higher erosion percentage contains high amount of burnt soil that has many rocky particles. This is due to better water absorbance capabilities, compactness, and particle size variety. Here are results for our second experiment. The general trend of burnt soil having a stronger shear strength than gardening soil and filtered soil having a stronger shear strength than unfiltered soil is observed, likely due to smaller particles than variety contributing more shear strength, and rougher particles increasing internal friction that endures shear strength. Here are the results for the third experiment. Generally, gardening soil has a lower angle of repose than burnt soil. We concluded that having a huge variety of particle sizes, harder particles, and rougher texture will lead to a larger angle of repose.
This graph shows an overall performance of each type of soil. It shows that both experiments are not related to one another, and that mixed soil is the best performing soil. We concluded that water absorbency and particle size variety are related, and an equal ratio boosts the performance of the soil. Therefore, a perfect soil should have that property, rougher and harder particles, and should be compact. The benefits of this project includes understanding shear strength and erosion resistance to identify correct soil types to build structures. With this, engineers can make informed decisions based on known factors and risks, applying them in construction sites and land reclamation to make buildings more stable and safe for everyone.
We would also like to express our gratitude to Mr. Simon, Ms. Shear, Ms. Elizabeth, Mr. Shobata, and Mr. Tan for guiding us through this project and giving us suggestions. Thank you.